All right, welcome to the Pythagorean Theorem practice test. Let's walk through this question by question. Make sure that you do the question and then watch the video and see how it was done. Wait and do the next one. So let's start with number one here. Straightforward question says, what's the length of a hypotenuse of the triangle below? We know this Pythagorean theorem where a squared plus b squared equals c squared. And the converse of that, if we put all these under that, we get the square root of a squared plus b squared equals c. And all we got to do is substitute these now. So let's substitute 33 squared plus 56 squared. I have to get a calculator behind me because I failed to do it to start with. But here we go. I got one now. Let's turn this thingy on. Doc B, clean that out. All right, so I'm sticking in. For everything square roots, I got 33 squared plus 56 squared. I get 65, and there's my answer. The answer is C. All right, so let's look at number two. Number two says a diagonal shortcut across an rectangular. Yeah, let me try that again. A diagonal shortcut. Oh man. A diagonal shortcut across an empty rectangular lot is 97 feet. That was a big sentence. The lot is 72 feet long. What is the other dimension of the lot? So first thing I'm going to do is I'm going to draw me a lot, a rectangular lot. It says diagonal shortcut is 97 feet. So it's 97 feet. And since this is a rectangle, remember those are right angles. The lot is 72 feet long. What's the other dimension? So it wants this right here, and that would be A. Now, inverting the formula, remember, if we did this formula up here, we had a squared plus b squared equals c squared. We can also take that and move things over. So if I have, don't have a lot of room here. So a squared plus b squared equals c squared. When I convert that around and I move things around, I can subtract b squared from both sides. And I end up with a squared equals c squared minus b squared, and we know that I can put that in there. So all I got to do is stick these in there. So I'm going to do my, remember, if I find the square root of a squared, it'll be a. So I'll need a square root of those. So square root of c is 97, so 97 squared minus b, which is 72, or 72 squared. Get out the handy dandy calculator. Turn it on. Control square root. 97 squared minus 72 squared. Hit my enter. I get 65. There it is again. All right. So good so far? Let's go down here. So number three says we have an isosceles right triangle that has legs that are 10 inches long. How long is the hypotenuse? Now remember, an isosceles right triangle. Boy, that was rough, huh? And I even drew it wrong here. I remember having problems saying things. Isosceles right triangle means that these two legs are exactly the same. They have the same measurement. And it says they're 10 inches long. So the legs are both 10 inches long. This is a simple a squared plus b squared equals c squared. And we know that if we do the square root of a squared plus b squared, that equals c. So I'll plug them in. I get 10 squared plus 10 squared. All I got to do is get the calculator out. Do that in. Control. Whoa, what did I do? The calculator, she shorted. All right, control. That. Delete. Control. All right. 10 squared plus 10 squared. I get 14.421, which is roughly 14.1 inches. This answer here, B, is correct. All right, we go to number four, and I'm actually going to get me a little sticky note so I can do this one, because remember, actually, I don't need a sticky note. I got it at the bottom of the paper. I said when you get to this kind of a problem, break it into two triangles. That way it's easier to do. So the box is 15 centimeters long. So the length here is 15 centimeters. It's 4 centimeters wide. That's 4. And it's 3 centimeters tall. What is the diagonal R of the box? So we're going to make two triangles. The first one is going to be this first part, and it's going to be 15. Boy, that's a teeny triangle, isn't it? 15 by 4, because these two widths are the same. And this here will be S. So to get that, we're going to do square root of 4 squared plus 15 squared, and that'll give us S. Let me get my calculator back out. 4 squared plus 15 squared. I get 15.5242. I'm just going to put 15.52. So S is 15.52. That's S. So I draw my second triangle, a little more to form this time. I know that S, this is the leg now. This is this right here, that's S, and that's 15.52. Now the height, that's this leg right here, is 3. Now I want to find R, which is this right here. Again, square root of 3 squared plus 15.52 squared. Calculator, going at it here. Square root of 3 squared plus 15.52 squared. Enter. I get 15.807. We're just going to call that 15.8, and there it is. That's C. All right. Let's move on to number 5. Make sure you're doing this right. Make sure you're doing the problems and then checking the answers, not the other way around. So, which set of 3 numbers can be used to make a right triangle? This is that function where we stick them in the calculator. A squared plus b squared equals c squared, and we see how it works. Always find c. Make your life easy. Always find c. So there's c for the first problem. I stick it in as 39 squared plus 41 squared equals 45 squared. It says false. A is out of there. Find the long one. It happens to be 59 again. I stick it in there as 39 squared plus 49 squared equals 59 squared. It says it's false. Going down here, again, 99 is the big one. It's kind of nice they're all in a line there, huh? So 39 squared plus 69 squared equals 99 squared. It says false. Well, I wonder if the next answer might be right. 89 happens to be C. You go 39 squared plus 80 squared equals 89 squared. And that one's true, so D is our answer. All right, distance formula. Distance formula says that D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Well, we could put in our points now. I'm going to call my points so I'll know what they are. I'm going to call this point 2. So this one's 0.2 and this one's 0.1 and do it. So I get the square root of 0.2, so x is 8. So 8 minus x is 20 squared plus 40 y2 minus 5 y1 squared. Get out my calculator. I start typing that in. So square root, yeah, it did it again. There's definitely something wrong with this calculator. So here we go. I got square root of parentheses 8 minus 20 out of my parentheses squared plus parentheses 40 minus 5 out of my parentheses squared. I hit enter. My answer is 37. So the distance is 37 units. All right. Now I got another one, but it's a little easier because it's on a grid. I love the distance formula. Okay, I lied. I don't love the distance formula at all. So what I'm going to do here is I'm going to make myself a right triangle because right triangles are far easier to play with than the distance formula. I got a handy dandy ruler. I'm making a right triangle. It's a very exciting thing. I've got an audience that are enthralled right now with making a right triangle. You can hear them. They can't hold themselves back. They wish they had paper. So this is easier. First thing I want to do is make sure I got the units. And you notice that I got 0, then a line, then 4. So every one of these lines is 2. I got to remember that. Now the easiest way is to count the legs, because this is a right triangle now. So I can just count the legs. 2, 4, 6, 8, 10, 12. So that side's 12. 2, 4, 6, 8, 10, 12. That side's 12. So now I'll just plug it in. And I got a squared plus b squared equals c squared. So I'm going to use the line down here because I got some space. So I'm looking for the square root of 12 squared plus 12 squared. And it says, remember up in our problem, it says to the nearest hundredth. So when I get my answer, I'm going to pay attention to that. So control there. 12 squared plus 12 squared. Hit enter. I get 16, and hundredth is 2 places. 16.97. All right, there's the front side. Let's do the back. All right. Number 8 is a review question all the way back to scientific notation for 568 billion. The easiest way to do this is write 568 billion. So 568, now it's 568,000. Now it's 568 million. Now it's 568 billion. So remember, you move to one decimal place. So we're going to put 5.68 times 10. And this is a bigger number. The number's larger than 1. So our power is going to be positive. And all we can do is count zeros and we go back. So start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10 to the 11th. Whoops. I said 11 and I wrote 10. 10 to the 11th. So it's 5.68 times 10 to the 11th. And that's one's done. All right, another Pythagorean Theorem problem. We've got C and A. Remember we said before that the square root of A equals C squared minus B squared. So now I got them. I'm going to put them in there. C is 53, so 53 squared minus 28 squared. Get out my handy dandy calculator. Square root of 53 squared minus 28 squared. Hit enter. I got a perfect 45. I love it when things work out perfectly. So the missing length is 45. So this one, number 10, is a distance formula question, but it's written a little differently. If you think about it, we have 2 points. We have negative 15, 8, and the other one is the origin, which is 0, 0. So distance formula says D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So I'm going to go through. I'm going to call this one 0.1 and this one 0.2. And the reason I'm doing that is because I love to subtract 0. In fact, I don't have to do it. So I just get 15 squared, because 15 minus 0 is 15, and 8 minus 0 is 8. So that made it real easy with the origin. Just in time for it to turn off. All right. Square root of 15 squared plus 8 squared, I get 17. So the distance between the origin and that point is 17 units. All right, number 11. On the grid below, you're going to draw a right triangle. That's as hard as it gets. Remember, always x first, then y. So P is 2, 4. So P, go over to 2, come up to 4. I'm going to label it as P. Q is 7. Go over to 7. Up to 9. 7, 9. I'm going to label it as Q. And R is 10 up to 6. 10, 6. And that's R. And then I'm going to draw it. I just got somebody who told me I did 7, 7. I did do 7, 7. Oh man, I feel bad. So it should be 7, 9. Whoops, now I'm going to go Q. Q. Thank you, mysterious person in the background who might be a 6th grader correcting me. That's okay. I do dumb things quite frequently. So it is a right triangle. It does look a little odd because it's not following perfect, but it's still a right triangle. It's just there's the right angle there. All right. So we got another question from the past. We got a slope question of the line of the graph for this table below. So slope is the change in y over the change in x. We got x on the top, change in y. What's the change in y? What's the difference between 3.5 and 5.5? It's 2. Change in x, 240 and 320. That is 80. So there's the difference. And it's moving forward both ways, so it's going the same direction. So we got a positive. Change in y is 80 over change in x is 2, and that equals 40. So that's the slope of the line. All right. Number 13. We got a photo. It's a 3-inch by 5-inch photo brought into a photo lab for enlargement. So I'm going to draw my lovely photo over here. Got a little picture, got some ears, little face. Got a text message. So there's my picture. It's 3 by 5. Which would be a similar enlargement for the photo. So similarity, we're looking for a ratio. So I'm looking for something that equals 3/5. That's the ratio there, 3 to 5. So 3/5. This is 4/6, which could be 2/3. That's not it. 5/7. That's not it. 6/10 simplified is 3/5. That's definitely what we want. All right, number 14. Parallel lines cut by transversal. Remember, we've got parallel lines cut by transversal. Congruent angles. All opposite angles are congruent, as well as corresponding angles. Because these are opposite, so 1, 5, 7, and 3 are all congruent angles. That means congruent means they are the same. So it wants to know which angle is congruent. I got 1 and 2. No, they're supplementary. They add to 180. 1 and 3. They are congruent. We said that already. So it's definitely B. 1 and 6, it's showing 1 and 6. They're really not anything. They're actually supplementary because these are congruent and these add to 180. 1 and 8, they're same side interior angles and they add to 180. Let's go to the very last question. It's number 15. It says, what's the equation for the data in the table below? So this is the first clue. Whenever x is always the top one, whenever x is 0, the y is the y-intercept. So they're kind enough, I know that I'm looking for y equals mx plus b. They were kind enough to give me b right here, that's 13.2. So I got y equals something, x plus b. Now, to get slope, remember, slope is the change in y over the change in x. So m equals the change in y, the difference between 13.2 and 13, which is 0.2. 0.2. Now, pay attention. It's going down, and this one's going up, so it's a negative slope. And the difference in 0 and 8 is 8. So 0.2 over 8. I can do my math here, so I just multiply both by 10. That'll get rid of my thing, and I'll get 2 over 80. Remember, if I multiply by 10, I just move the decimal one place over. So 2 over 80 is simplified is 1 over 40. I can't get any simpler, so, and remember it's a negative. I said that up front, and then I almost forgot it. It's negative 1 over 40x plus 13.2. Well, hope that was helpful.